if you can't hear the voice or you can't see the PowerPoint, please report in the WeChat group or report in the Tencent meeting. I can see it also. Today we will introduce the matrix method for the network. Matrix method because our course name, sorry, our course name electric network. The first thing we discuss is use the matrix to express the electric network. We should have learned in the undergraduate course, but for international students, I think maybe most of you have not learned this course. If any of you have learned this content, you can report to me. The key point, the concept of the three matrices: incidence matrix, loop matrix, cancelled matrix, and the basic loop matrix. And then we will discuss the loop current function, node voltage function, and cancelled voltage function. To introduce these two part contents, we should introduce several concepts at first. The first concept, the topology of circuit. What means the topology of mathematics? It comes from the scientist order. And it original from the Königsberg 7-bridge small town in Russia. And for this small town, there was a river. This is a river. And two islands. This mainland. There are total 7 bridges. 1, 2, 3, 4, 5, 6, 7. Bridge. So if one start at one point, any point, for example, start from point, if we try to walk along all the 7, but without repeat, run through all the bridge, but without run this way. Then repeat. The question is, if one can find a method to pass through all the 7 bridges, but without any repeat. And then at that time, no one can solve this question. This problem was sent to this river and the island to a topology. The question turned to from one point, and draw this figure without any repeat. And the answer is negative. That means impossible. It's impossible to draw the 7 figure without repeat. And then the science order founded the course of topology. This is a mathematical topology. We care about the circuit topology. For this circuit, when we discuss topology, we don't care about, sorry, wait for a while. I will try to record it. Wait for a while. Appearance, recording 100 minutes video, it will be total around 100 MB. 100 MB. It's not too big. I'm recording the also. Let's continue. The topology of circuit. When we discuss the topology, we will ignore the components. We don't care about the components. We just care about the connection. So the branch 8 means this current source. Branch 3 means this resistor. So we treat every one component as one branch. So this is topology. The topology is a connection of a circuit, but without or we don't care about the components. This is one kind of topology. But for the circuit, for this circuit, we will have n means nodes. We have 5 nodes, 1, 2, 3, 4, 5 nodes, and B means branch. We have 8 branch, 1, 2, 3, 4, 5, 6, 8 branch. And for the circuit, we always treat the serial or parallel components as one branch. For example, these two are parallel connected, so we treat them as one branch. The branch 3. So it's 2 components. And for these two components, they are serial connected, so we treat them as one branch also. The branch 6. So this branch 6 is these 2 components. By this definition, the topology will be simpler. For this topology, it have 4 nodes, and only 6 branch. But for this topology, it have 5 nodes and 8 branch, because this node be ignored in this topology. And for the topology, we always add the direction. This direction means the current direction, also means the voltage direction. For example, for the direction 4, it means for this resistor, the current, this I4, flow from down to up. And the U4, we use passive sign convention, this U4. So this arrow, this direction means current direction and also voltage direction. We call this figure as digraph. Digraph means the topology with direction, with current and voltage direction, this diagram. So in the coming contents, all our discussion based on this kind of topology with direction. Conclusion: the topology of circuit expresses this connection of components. The branch and the node is a topology. In the topology, in the topology is one-to-one corresponds to the circuit branch and node. This is a definition of topology. The definition of graph. The graph consists the branch and the nodes. For example, so this node, and this is branch. This branch, we have 1, 2, 3, 4, 5 branch, 4 nodes. The node and the branch are separated. If we remove the branch, the node it still exists. For example, in this figure, we remove this branch. The node it still exists. Remove these 2 branches. But if we remove the node, all the related branches should be removed also. For example, in this topology, if we try to remove this node, we should remove node and this branch also. That means the node can exist normally, but the branch can't exist normally. The branch only connect nodes. This is our definition. Path. The concept of path. The path means from one node of the graph move to another node. All the branch is a path. For example, from the node 1 to the node 4, 2, 3. So this is a path. This is a path. This is also a path. This is also a path. This is also a path. Pass from one node to another node. All the branch is passed. The connected graph. As for the definition of connected graph, any 2 nodes of the graph. For any 2 nodes of the graph, we can find at least one path. For the non-connected graph, this is another concept. The non-connected graph will have at least 2 separate paths. It also can call as a separated graph. For example, from this node 1, 2, 3, 4, 5, 6, for this node 6. For any 2 nodes, from the node 1 to node 6, there's no path from node 1 to node 6. No path. So for this figure is non-connected graph. If there's a branch here, so this is a connected graph. So this concept is connected and non-connected. Graph. For the transformer, transformer is non-connected. This is non-connected. Subgraph. If nodes and branches of the graph G1 all come from the nodes and the branch of the graph G, so we call the G1 is a subgraph of G, or we can treat the G1 is the sum of the G. For example, this graph G, G1, the nodes of G1 all come from the G. 1, 2, 3, 4. This is 1, 2, 3, 4. And these 3 branches. So the G1 is subgraph of G. This is also the subgraph of the G2. Also the subgraph. of the G. Definition of tree. Tree, we all use T to mean tree. Tree is a subgraph of a connected graph G, and A, the tree should be connected. B, the tree should contain all the nodes. And C, the tree can't contain any closed loop. This is the definition of the tree. It has three conditions: connected, contain all the nodes, but don't contain any loop. For example, for this topology, this is a tree. Because it contains all the four nodes, all nodes, and connect all the nodes, connected. And it don't contain any loop. If we add this branch, so this will be a loop. So it's not a tree. So this is also a tree. But for this one is not a tree. This is not a tree because it have a loop. So the tree means connect all the nodes of a graph, and we the list branch. The tree means the list branch connect all the nodes. Core tree. What means core tree? Core tree means the branch belong to the graph, this graph, but don't belong to the tree. For example, if we define this tree, so we remove this three branch, then this branch are the core tree. For a one graph, there will be many different trees. For example, this one kind of tree, this another kind of tree, and we can also draw, for example, 1, 2, 3, 4. This is also a tree. And this is also a tree. So for any given one graph, there will be many different kinds of tree. But the tree branch number is certain. For example, for this tree, the branch number is 3. This tree branch number is 3 also. For this tree, 3. The branch number is certain, and the number is BT. This B means branch, T means tree. The tree number will equal to n minus 1. The n means the node number. So the tree number will equal to the node number minus 1. Why? Because the tree connects all the nodes. For example, if we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. These nodes, we try to connect them together. We draw the first branch. The first branch connects two nodes, and then we add the second. Add one more branch, they will connect one more node. So the branch number is a node number minus 1 because the first branch connects two nodes. The core tree number. The core tree is remove the tree. The left is core tree. So the core tree number will be the total number. We always use L. This L means core tree. L is loop. is loop, and loop always corresponds to core tree. We'll explain later. The core tree branch number equal to the total branch number minus the tree branch number. And the tree branch number is n minus 1, the node number minus 1. So this is core tree number. Core tree number. Loop. The definition loop is also the subgraph of the graph G. It forms a closed path, and at first it connected. Second, the one node should relate to only two branches. For example, this loop. Every node connect two branches. But for this is not a loop, because these nodes connect four branches. So this is not a loop. We can't treat this as a loop. This is not a loop, because these four nodes. This is a loop, but this is not a loop. This is not a loop. One graph will contain many loops. But the basic loop number is certain. The basic loop number is core tree number. For the planar circuit, the mesh number is basic loop number. We have several concepts here. Sorry, I will add one more to explain. We have two more concepts. The first, basic loop. What means basic loop? Because every loop, it will correspond to a keyword function. For example, for this set, we have three loops. One loop, this loop, this also a loop, We have three: loop 1, loop 2, this is loop 3. We have three loops. Every loop have one keyword function. So for the loop 1, we can write the keyword function 1. For loop 2, we can write the keyword function 2. For the loop 3, we can write the keyword function 3. But for these three functions, they are not independent. We can use the function 1 and the function 2, get from function 1 from function 2 to get the function 3. So these three are not independent. If the keyword functions are independent, this keyword function, the loop 1, loop 2, and loop 3, these two are independent. So loop 1, loop 2 are independent loop. We call loop 1, loop 2 as basic loop. Loop 1 and loop 3 they are independent also. So loop 1, loop 3 also independent loop. So also basic loop. And loop 2, loop 3 also independent loop. But 1, 2, 3 are not independent. This means basic loop. Basic loop means independent keyword function. This is first question. Second question, what mean planar circuit? The planar circuit means we can draw a circuit in the two-dimension planar without cross point. For example, we have a circuit with 1, 2, 3, 4, 5, 6 nodes, and this is one branch. This is one branch also. This is one branch. This is one branch. This is one branch. And this is one branch. This is one branch. Now we try to connect this node, this node 1, this node 6. If we try to connect another component from node 1 to node 6, we have to draw like this. So this figure, this line have cross point with other branches. So we should use a 3-dimension figure, 3-dimension space can draw this figure. We can't draw this figure in a 2-dimension. But for this figure, we can draw it in the 2-dimension without cross point. For this figure, we can't draw in 2-dimension. We should use a 3-dimension to express. We draw this branch. This branch means connect node 1 with node 6, but without connection to this branch. So this is not planar circuit. This is planar circuit. This is the basic definition. And the basic loop number is certain. It's Cauchy number. Why? Why is Cauchy number? For example, for this figure, if we define these 4 branches are trees, so the left is Cauchy. When we add one Cauchy, there will be one loop. So the Cauchy number is a loop number. And for all these 4 loops, they should be independent because every loop contains a new Cauchy branch. So the basic loop is Cauchy number. This is why we use BL to express Cauchy. The L always means loop. The loop number is Cauchy number. So we use BL to use a Cauchy number.
Me, sir.
Basic loop. The basic
Can you
loop
hear me?
is one Cauchy loop. For example, for this figure, we choose 1, 2, 3. 1, 2, 3 as tree. And this is for nodes. Then 4, 5, 6 is a Cauchy. Add 5, so this will be a loop. Add 6, this will be another loop also. And add 4. When we add 4, if add 4, this is 4. So this is Cauchy, this loop. So the basic loop is one Cauchy loop. This is equal. Basic loop is one Cauchy loop. So one Cauchy plus tree can form a loop. One Cauchy plus tree form loop. The conclusion: the total branch is tree number plus Cauchy number. The tree number will be node number minus 1. The Cauchy number equal to the basic loop number. So the tree corresponding node, Cauchy corresponding the loop. the B means total branch, the N means nodes, N minus 1 is tree number, the L means loop, this loop, this nodes, this nodes. So this function contains the branch, the nodes, and the loop, node, branch, and the loop function. For this diagram, draw 3 different trees and the corresponding basic loop. For example, we choose 4, 8, 3, 2 as tree. So this core tree, and this 5, 6, 7, and 1 as core tree. 1, 5, 6, 7 core tree. 2, 3, 4, 8 tree. This tree. So when we add the core tree 5, this loop is basic loop. When we add the 7 and 7, this basic loop. When we add the 6, this basic loop. When we add the node, the branch 1, this basic loop. 1, 2, 3, 4, this basic loop. And the mesh, pay attention, the mesh. Mesh is a basic loop also. The mesh means the loop. What is the mesh definition? The mesh is a loop, but the loop not contain any other loop. Not contain any other loop. Not contain any other loops. For example, this one is a mesh, but for this loop is not a mesh because this loop contains this loop also. So in this figure, only these 4 loops are mesh. This one is not a mesh. This one is not a mesh also. This is a mesh and loop difference. Mesh loop difference. For the mesh is also basic loop. The basic loop means only one branch, only one core tree loop. When we choose 5, 6, 7, 8 as the tree, so this core tree mesh is loop. This core tree is a mesh loop. This core tree is a mesh, is a basic loop. This core tree is a mesh. So basic loop equal to one core tree loop. For this tree, so this will be a basic loop. This will be a basic loop. And this core tree, basic loop. This core tree, basic loop. The concept of the cut set. The cut set are the set of branches. It's branch set, and which at first, if we remove all these branches, the graph will be separated to 2 parts. And if we reserve any one branch of the cut set, Q, we always Q to express cut set. The graph will be still connected. For example, for this figure, if we remove the 6, 3, 8, it will left, for example, this is 1, this is 2, this is 9. 4, 5, 7. If we remove this 3, 6, 8, remove all this branch, the graph will be separated to two parts. If we resolve any one branch of Q, the graph will still be connected. For example, if we resolve the 6, so it's still connected. Or if we resolve the 3, also connected. Resolve the 8, connected. So the 1, 9, 6, this also a cut set. 2, 8, 9, 2, 8, 9, also cut set. And 5, 7, 8, also cut set. 6, 4, 7, cut set. This cut set. This is all cut set. Maybe you will see why this are cut set. For example, when we remove the 1, 6, and 9, the nodes connect left. This left, and this part left. These are also two parts. So this is also a cut set. This node connected. Also two parts. The discussion for the 3, 6, 5, 8, 7, 3, 6, 5, 8, 7. Is it a cut set? Is a cut set? If we remove this, so this part left, this part left, and this node left. So it will be 1, 2, 3 parts. That means remove all these branches. There are 3 parts left, not 2 parts. So it's not a cut set. Not a cut set. And then it's got 3, 6, 8, 2. 3, 6, 8, 2. If we remove this 3, this 4, so this part left, and this part left. There's still two parts. But when we resolve any branch, for example, resolve the 2, the graph is still not connected. So these are also not cut set. So the cut set means the minimum branches which cut the circle to 2 parts. This means Y cut set. Cut the circle to 2 parts. For example, this cut, and this also cut, and this also cut. This means cut set. Cut the circle to 2 parts means cut set. The basic cut set. If the cut set contains only one tree, we call it the basic cut set. So the basic color set number is a tree number. This n minus 1 is a tree number, is a node number minus 1. For this figure, we choose 1, 2, 3, 4, 5 as tree. So the 6, 7, 8, 9 is core tree, a core tree. So core tree. So add one tree for this tree 1. So this color set. This color set. This is also basic color set. Basic color set. And this basic color set. Pay attention, the core tree can't form color set. Why? Core tree can't form color set because if we remove all the core tree, the graph, the topology is still connected. For example, remove the 6, 7, 8, 9, it's still connected. Still connected. So the core tree can't form color set. The branches of one color set will conform to KCL. If all the branches connect to one node, the color set KCL is actually not KCL. So what does this mean? For example, we define this I6, I3, I8. The branches of one color set will conform to the KCL. This means the I6 plus I3 plus I8 will equal to 0. This is KCL. Because this part, we can treat this part as one node, this part as one node, so these three can't conform KCL. The first sentence means. The second sentence means if all the branches connect to one node for 5, 7, and 8, all the three branches connect to this node. So the color set KCL is actually node KCL. The I5 plus I7 plus I8 equal to 0 also. So this node KCL. This node KCL. This form, and for this form, we call it as a general node. Node KCL. This node KCL, general node KCL. So the color set corresponding to the KCL function. Color set corresponding to KCL. And the loop corresponding to the KVL. The basic color set means one tree color set. The basic loop means one core tree loop. Okay, let's have a break, 10 minutes. Let's have a break, 10 minutes.